So y'all should have received the practice final. Your actual final will look extremely similar to this, just kind of a different configuration. The intent of this is to be a very straightforward set of drawings. I've kind of drawn it myself just to make it just really easy. I don't want this to be a review of your ability to look through a set of drawings quickly, because that's not the intent of the class. It's for you to be able to quantify scopes of work and apply pricing to it. So I'm going to walk you through exactly what you're going to be expected to do, and you should be able to repeat that process come Monday, and with any luck, you'll knock it out real quick. Okay, so sent you these drawings. First step, since this is something I've drawn manually, it's not, there's not like a predefined scale. So first thing you need to go do is go to Edit, Calculate Scale, and then you're going to type in a known distance, which is, in this case, 120 feet from here to here. So I'm going to type that in, 120, and then add your inches, so 120, 00. Don't click on OK yet, just click right to either end of that dimension line, then you can hit OK. Whenever you auto scale, you should always pull a dimension to make sure it's correct. Looks good to me. So give y'all a minute to load your drawings and to calculate your scale.
Do it twice for all pages?
Yes. You probably should calculate the scale independently on the other page. Okay, so next step. Any questions?
Where do I click? It wasn't loaded, I'm sorry.
Yeah. So to auto calculate a scale, which is a very common thing you're gonna have to do in the real world, because these things are often not to scale.
Okay.
Go to Edit, Calculate Scale,
Mhm.
and then type in the known dimension. So the known dimension is 120 feet. And so that's 120, but then 00 for inches. And then don't click OK, don't click anything else, just click on either end of that dimension line, like so. And then you hit OK.
Okay.
I've estimated many a job off nothing but scaling a door, a 3-foot door.
Okay.
Yes. Okay, so first thing we're gonna do is pad footings. So I'm gonna create a new estimate. I'm gonna start with building concrete. So file, save as. Practice final. Name, practice final, date. Okay, first thing I'm gonna do is get rid of pedestals and walls. The final will not have pedestals or walls, so just gonna get rid of those. So select everything from pedestals to the bottom of the walls and click delete. And this estimate had 2 separate slab-on grades. We only have 1, so I'm gonna get rid of my second one. Okay. So first thing we need to do is quantify how many we have. So let's see, that's can certainly just do a count function. Count 7 by 11, so 77 footings is what I come up with. So I have 77 to lay out. Next question is, how much excavation is required? So I've got pad footings, 6 foot by 6 foot by 2 foot. And I'm gonna put the bottom of footing, that it wasn't noted on here, but I will on the test, note that the bottom of footing is 3 feet below slab. So 6 by 6 by 3 by 77. So how much excavation do we need to complete? 77 by 6, 6, and 6 feet wide, 6 foot wide by 3 feet deep of excavation, divide all that by 27. All right, how much concrete do we need for our pad footings? It's gonna be 77 footings times 6 feet wide times 6 feet wide times 2 feet thick. Got to divide by 27. There we go. Placing the concrete is going to be the same value as the actual concrete itself, so it's easy. And then finishing the concrete is the surface area of the top of the pad footing. So there's 77 by 6 by 6. So it's 2,772 square feet. We're not making any adjustments for the final to our material pricing or our production rates. So we are done with pad footings. And we're gonna move on to continuous footings. Any questions on pad footings? Okay. So continuous footings go around the perimeter of the building. They are 5 foot wide by 2 feet thick. They will also have a bottom of 3 feet. The bottom of footing is 3 feet below slab. And then we just need to calculate how many lineal feet there are. We can do a little bit of math, multiply out, but I'm just gonna do linear. So linear, this is going to be continuous footing. There's only one type, so no need for any additional description. And I'm going to go from pad footing to pad footing. Pad footing, or I'm sorry, the continuous footing does not extend below or above pad footings. I'll give you a few minutes to get that finished. Okay, so I came up with 434 linear feet. So my layout is 434 linear feet. Excavation is 434 times 5 by 3. It's 5 times 3, again, bottom of footings 3 feet deep. Add all that by 27. Concrete is 434 by 5 by 2. Divide that by 27. Placing the concrete's the same value as the concrete itself. Finishing the concrete area is the surface of the top side of your footing, so that's 434 feet times 5 feet wide. 2,170. Yep. Remember that. Give y'all a minute to finish that. We'll move on to slide on grade.
Can you show the formulas for, excavation?
So it's the length times the width times the depth divided by 27. Nothing else. I want y'all to be able to just immediately be able to say length, width, depth when you're calculating volume. Okay. So next, we're gonna move on to slab on grade. Okay. So. Slab on grade forms, oops, linear slab on grade forms. So we're gonna form the perimeter of the slab. So I came up with 653 linear feet. Excavation is 0. You won't need to excavate anything. Backfill 0. Formwork is, how thick is my slab? 1 foot by 1 foot turn down, so your slab's at the edge is 1 foot tall. So that's equal to 653 times 1, so 653 square feet. For vapor barrier, we need the area of the slab. So area, slab on grade. $24,932. $24,932. For the gravel, we need to figure out how thick the gravel is. It's 4 inches. So this is equal to the area times 0.334. Divide that by 27. And concrete. 4-inch slab with a 1 foot turn down. this is equal to 24,932 times 0.334 plus the perimeter of 653 times 1 foot thick times 1 foot thick. And wrap that whole thing and divide by 27. So it's the area of your slab, about 4 inches, plus the perimeter of your slab times the 1 foot by 1 foot turn down. And then all of that's divided by 27.
What did you do for gravel again?
Let's see. That is the area of your slab times 0.334 for 4 inches. Then that's wrapped in parentheses, divided by 27.
Can you get back to the last formula?
Which one?
Uh,
The concrete?
yes.
Okay. Let's see here, place concrete, it's just the same as the volume of concrete, so that's easy. Finished concrete, it's the area of your slab. Saw joints, we're gonna need to calculate those, so come over here. Put this on a layer, slab on grade. Okay, saw joints. Add layer, saw joints. Okay, I'm gonna go plow through the columns. It's a little lazy. Alright, I came up with 2,042 linear feet of saw joint. And then sealers equal to the area of your slab. Also going to adjust my slab. That's not that hard to type in. Okay, that's it. Concrete estimate's done in about 20 minutes.
Did you show your form, please?
Yeah. Give you all another minute to wrap it up and we'll move on to steel. Okay, any questions on concrete? All right. So we go to the next sheet. We have structural steel. Going to go to edit, calculate scale. 20, 0, mark the corners. And okay. Then check your scale, just be sure you didn't make a mistake. Looks about right to me. Okay, so what do we have here? Again, almost artificially easy. Drawing, everything's W18 by 35. Columns are gonna be 20 by 40s and they're 22 feet tall. Easy. Okay, so I'm gonna go to my steel template, my splash steel homework, Control C, Control V, and this is practice final steel. Okay, so you guys are not gonna have to calculate, labor on this, that's too, subjective for final, so we're just gonna delete the labor side. You're not gonna have any braces for this. Okay, let's get it. So we need to calculate our beams. Linear, this is a W18 by 35. I'm just gonna select it and paste it. Then select 2, copy, paste. Select 4. Copy, paste. Okay, came up with 2,709 linear feet of W18 by 35. 2,709. So this is equal to 2,709 times 35 pounds per foot divided by 2,000 pounds in a ton. So we've got 47.41 tons of beams. columns, we already counted our, foundations, there were 77. So they're 40 pounds per foot and they're 22 feet tall. So this is equal to 77 individual columns times 22 feet tall times 40 pounds per foot divided by 2,000 pounds. Alright, base plates, this is equal to 77 base plates, and there's not a detail here, I'll provide that to you on the final. There's 77 base plates that are gonna be 1 foot by 1 foot by 1 inch thick, which would be 0.08. 0.08. And then that gives me cubic feet times 450 pounds per cubic foot. And divide all that by 2,000. 1.39 tons. So 77 base plates, they're 1 foot by 1 foot by 1 inch, 0.08. And then that gives you cubic feet. Multiply that by 400, sorry, I think I said that wrong. 490 pounds per cubic feet, not 450. 490. Because the weight of steel is 490 pounds per cubic foot. Then you divide all that by 2,000 to get tons, 1.51 tons. And then the roof deck is 120 by 200, the dimensions of your building. So 120 by 200. $2,400, 24,000 square feet. And we're done. Say that was 6 minutes.
You can click back on beams.
So that's it. I'm here for any questions you have, any help you might need. That's it.
Did you show it for me?
So I'll take a poll or a question here. For next class, for estimating 1 next semester, I'm considering going to just calculators and paper, Excel files. Instead of using Excel, just doing it all on paper. Do y'all think you would get more from learning this on paper or using Excel?
I think paper, it would solidify more.
It's kind of what I'm feeling is, there's too many people that are dependent on formulas and not understanding the basic math.
I was like, Excel's phenomenal for what it is and what it does, and it's great for when you do this for a living. But when
You almost would need
learning
to take
it-
an Excel class.
Yeah.
Before, just so you know it.
Which I have recommended that they add that to the curriculum, that in my mind, y'all should have all taken advanced Excel. It used to be the curriculum, I don't know why they for some reason think y'all are computer wizards, but I don't see it, to be honest.
But yeah, it's kinda shocking how many people don't, I think, know Excel
Yeah.
very well.
Like, Yeah,
'Cause I mean,
y'all's
Excel's my
generation is
life
not as
for
good
it.
on computers as mine.
Well, I didn't.
They're not.
We didn't do that.
like, Excel's my lifeblood, so I use Excel constantly. But the amount of people that I have that come to me, they're like, I don't know how to, I'm like, whoa, hold on, what?
Also, I can run Navisworks, but I can't run Excel.
We made it
Think
through.
about that.
I was, I mean, in all seriousness, most people were, in my generation, most people were experts in Excel and Word out of high school. Like, you knew you had to be good at that. And like, that's just dropped off.
They just don't prioritize it. I don't know why.
We
So you
were
graduated like
required
4
to
years
take
ago.
it in high school, like, before I graduated, we were required to be licensed by Microsoft.
Yep.
So when I
Yep,
was
we
in
had to
high
take the Microsoft class
Yeah,
too.
when I was in high school.
Bryce, when you-
Well, I'm older than you, Carla,